I did not hit the record button properly when I was sketching the graphs of these logarithms. So I'm just going to use a static picture and talk through how you would do this with the picture. If I want to graph log base 2 of x minus 3, then the fastest way to do this really is to just take the graph of log base 2x and push it down 3 units. And for the graph of log base 2x, you find the vertical asymptote by setting the stuff in parentheses equal to 0. That's x equals 0. You get the x-intercept when that stuff equals 1, and the stuff in parentheses is just x, so that's at x equals 1. You get y equals 1 when the stuff in parentheses is equal to the base 2, and that's just x equals 2. So that's a really simple one to graph. You plot the 2 points that you have, plot the vertical asymptote, connect the curve, and then to get the graph of log base 2 of x minus 3, just push it down 3. For the graph of y equals negative log base 2 of x, we take the graph of log base 2 of x that we had before, and we know that if you multiply that by -1, that just changes all the signs of the y values. So you're just going to reflect your graph over the x-axis. And then for 3 times log base 2 of x, we know that if you take a function or an equation and you multiply it by some constant that's bigger than 1, it's going to vertically stretch it out. So if I multiply log base 2 of x by 3, it's going to take all of my points and stretch them out by a factor of 3. So where I had y equal to 1 earlier at x equals 2, now I'll have y equal to 3 there. So that's how you get this red graph.